In this week's examples, I'm going to go through 3 simple demonstrations that relate to the tutorial content around for loops. In the first example, I'm going to just demonstrate the skeleton of a for loop and show you a pattern that you can apply again and again for creating a loop that counts from 0 up to some number. And if you can remember that pattern, you can adapt that into pretty much any use you have for a loop. In the next one, we'll start to add some user interactivity and we'll make our grid react to keyboard presses from the user. So what I'm thinking there is one key to change the color and then another key to increase and decrease the size of elements in a grid. And we'll be using a for loop to draw that grid. In the third part, I'll show something that's actually not mentioned in the tutorial notes, but might be of interest to you, and that's actually how to use a mouse to make that grid reactive. So what I'm thinking there is, as we move the mouse around on the screen, elements in the grid will get larger or smaller, depending on how far away they are from the mouse. Let's dive in to the first example, where I'm going to just demonstrate the nuts and bolts of a for loop. So let's say for, and then round brackets, and then curly brackets. So there's the skeleton of a for loop. The keyword for, followed by round brackets, and then followed by a block that's surrounded by curly brackets. Now, usually you put more than this in. You actually have to put some more in here. So we have to put in 3 parts into that first part where the curly brackets are, and they're separated by semicolons. So this is not a function, it's a keyword, so it's a little bit different to how we've been calling functions. So what we're going to have is an initialization part followed by the semicolon, and then an update part followed by the semicolon, and then followed by a condition part followed by the semicolon, followed by an update part followed by the semicolon. And then inside the for loop, inside the block that's surrounded by the curly brackets, we're going to have one or more statements. Okay, so let's talk through what each of those parts do. So firstly, let's just imagine that we're going to loop 10 times. I want this loop to happen 10 times, and I'm going to draw 10 random circles. So each time the loop happens, I'm going to draw one circle and randomly place it somewhere on the canvas. So probably the easiest place to start is actually the statements, right? So I could say circle, and I'll just use some little temporary variables to make it clear what I'm doing. I'm going to say let x equals random width. And we covered how to do this in last week's tutorial where we used the random function to control shapes in different ways. So x equals random width and y equals random height. Then I'm going to just say circle x, y with a radius of 50. And I'm going to make my background a little bit darker so it's clearer to see. I'm going to add the no loop, a call to the no loop function to stop the draw loop. So the draw loop will only happen once. So normally in P5.js, setup happens once and then draw loop gets called repeatedly. You can think of it in a way as sort of like a loop, but it's actually not the same kind of loop that we're using here. It's really a function that just gets repeatedly called. And we can stop that function, that draw loop, by calling no loop. And then we can start it again later with another function called loop. So here what's going to happen is we're going to set up the sketch, run through draw once, and then stop. I'm just doing that so that we don't get kind of randomly flashing circles. I can show you what will happen if I do that. Oh, I got ahead of myself. So I wrote what would be in the statements, but I actually didn't fill in the first part of that for loop. And you can see the error that I got there at the bottom. Let's just open that up. Syntax error, unexpected token, semicolon. Basically, it's because I've just put in human words here, init, condition, and update, rather than the actual statements. Actually, there's not a semicolon after that last update. That's the actual error. Yeah, I get a reference error. Init is not defined because I just put in that word without doing an actual expression there. So let's look at what those are. So I'm going to say let I equals 0, and then I is less than, now we wanted this to loop 10 times, so I'm going to say I is less than 10. And then each time through, I is going to increase by 1, I plus plus. So that will make our loop go 10 times. And you can use this pattern anytime that you want a loop to go a certain number of times. For let I equals 0, I is less than whatever number of times you want it to loop, I plus plus. Let's run it, and we should see 10 circles on the screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I think that's right. And just to demonstrate, if we only wanted that to run 4 times, we'd put in 4 there. 4 circles. If we wanted to run 400 times, or 4,000, we put in 400 or 4,000. And I'm not going to try and count that. Let's go back to 10. And what else should I tell you about at this stage? Yeah, I think the thing I want you to get out of this is actually this pattern is really, really commonly used. It's probably the most common way to write a for loop. You can do other things, and let's actually look at some of those in a second. But you know, you could do things like starting I at 10 and then counting down to 0, decreasing I by 1 each time. So you can actually count backwards. You can count up in 2s or 10s. You can start from 50 and go to 75. All of that's possible, but usually this simple version, if you just think about the number of times that you want to loop, this is often the easiest way to think about constructing a for loop. But I'll show you some of those other variations in a second. Let's switch now from a circle to a series of lines. I'm going to say line from X. So I'm going to let them, yeah, I'm going to say, I'm just going to get rid of the I for a second, and I'm going to just make 10 random lines that go down the page. So it's going to be from that random X position and 0Y to that random X position and the height of the page, of the canvas. And then we should get 10 separate lines. There they are. Now, I'm doing this because I want to sort of illustrate how we can manipulate the elements of that first for statement to change what we get. But what's going to make that clearer is if instead of making that X position a random number, I actually make it directly equal to I to begin with. So let's run that. We should see sort of a black strip just down the left-hand side of the page. And to make it a little bit clearer, I'm going to change the stroke color to be, make the stroke color white so it stands out on the page. Yeah, so you can see that thick line, it's actually 10 pixels wide. In fact, it's 10 individual lines. So let's make that go all the way across the width of the canvas. So if we change this from 10 to the width to 400, we'll now get a fully white canvas. It looks like we've just filled in the background, but it's actually 400 individual lines going across the canvas. If I change it to 200, it's only going to go halfway across the page. So let's go back to, let's say, 50 lines. Okay, that's going to be 50 pixels wide, but now let's space them out a little bit more by changing the update. So instead of going up by 1 pixel each time, I can say go up by 10 pixels each time. So now they're more spaced out, right? But they're still ending at 50. So if I want them to go further across the page, I need to increase that 50 to, let's say, 400 again. And then I get some number of lines across the page, each spaced out by 10 pixels. If I wanted this to start at the middle of the page and go to the end, I can just change the first part. So I'm going to start at 200 and go to the end at 400. I'm going to start I at 200 and keeps counting up by 50 each time until it gets to 400 and then stops. So I said before that often a better way to write these loops is to think about the number of times you want something to loop and then map that onto your value of x or y or whatever in the loop. And usually it's a bit of a toss-up sometimes, but let me show you how we would do that in this case. So let's just think a minute for how many times it's looping, right? So we've got 20 lines going across the page there. So if we just write that as a for loop from 0 to 20, where I is increasing up by just 1 each time, then what we can do is here, instead of just saying let x equals I directly, we can map that value of I to some value of x. So we know that I is always going to go from 0 to 20. And we want to map that from 200 to 400, right? So to the right-hand side of our canvas. We get the same effect, but this can be a little bit easier to work with sometimes. So like, especially if I wanted to change it to go from like 150 to 350, just change those last two numbers there. And I talked about how the map function works in one of last week's examples. So you can check that out for more of an explanation, or it's also covered in some of the tutorials. Okay, so that's a single for loop. What we've looked at there is the for keyword, the round brackets that surround the initialization, the condition, and the update, and then the curly brackets that surround the block of statements that gets executed each time the for loop runs. And then after the for loop ends, we just go to the next line of code, whatever it is. Here it's no loop, and we just execute that code and keep going through the program. Now, one thing we can do is actually take a single for loop and then put it inside another one. And this is one of the tricks that we show in this week's class. I'm going to draw a grid now of 10 by 10 circles. So let's just start by making a line of 10 circles. So I'm going to map I, which goes from 0 to 10, to go from x equals 10 to x equals 390. And I'm going to draw a circle at that position. That's that x, and for y, I'm going to put 200. And I'm going to make the diameter of the circle 20. So let me think. Actually, x is going to go from 0 to 9. I had a mistake there. That's right. Let me talk about what I did wrong there. So the way this map function works is you give it a value and the range that you expect that value to be in. So from 0 to 9, and then you tell it what range you want to map it to. The reason I've got 0 to 9 here is actually because the values that this I actually has, even though we're sort of saying x is going up to 10, actually never getting to 10 because it starts at 0 and then 1, 2, 3, 4, keeps looping that whole time, 5, 6, 7, 8. And then 9 is less than 10, so it will loop. But then when it comes back and does the update, I get changed to 10. And then here in the condition, when I equals 10, it's actually not less than 10, it's equal to 10. Then it leaves the loop. So the highest that I ever gets is actually 9 in the loop. A good way to see what values you're getting in a loop is to use the console.log statement. Console.log will print out information to the console at the bottom of the sketch, and you can see here that our value of x is going from 0 up to 9. If I change this to 20, it's going to go from 0 up to 20. Up to 19, not up to 20. So that's actually, yeah, that's a good little one to talk about. So we know that our value of I goes from 0 to 9, and we want to map that from 10 to 390, just so those circles are nicely spaced out. I actually might make that go from 20 to 380. Now this is the advantage of the map function, because I think each of those would be like 19 pixels apart. Let's actually use console.log to see what value of x we're getting there. So console.log I and x. Yeah, so, okay, it's going up by 40 each time. So, but let's say I wanted to have a margin of 22 pixels on each side. Then it's going up by some weird decimal. And this would be really hard to write as the conditions and updates for a for loop, right? To get your value of I directly to go through these numbers would be quite challenging. But if you can just think in terms of how many circles you want, then you can leave the calculation of that x position to the map function. And it takes care of like the complicated maths for that for you. So that's why I find map is often a lot easier to use. Just go back to a nice even a nice even margin. So now we've got one row of circles just using our single for loop. And now if you think about it, if we take that one row and just repeat that down the page, right? We got that row by repeating a circle from left to right across the page. Take that whole row and now repeat it from top to bottom down the canvas, we'll have our grid. So all we need to do is say, take all of this, and I'm going to just put a comment in the middle part here. Right, so this draws a single circle at x determined by I. And this whole loop, it draws a row of circles. I'm going to take all of this code here and treat that as a block of code that we're going to put inside another for loop. It's inception of for loops. Probably not as exciting a movie as the original Inception, but there you go. So here I'm going to say for let j equals 0, j is less than 10, and j plus plus. I'm using a different letter because I'm going to put these for loops one inside the other, so I need to have different letters for the outer loop, different variables for the outer loop and for the inner loop. Draws a grid of circles. And so j is going to relate to my y value and I is going to relate to my x value. So here where we've got x, let's do a similar thing for y. Let y equals map, and instead of I, we're going to map j onto some number that, from some number that goes from 0 to 9 to a number that goes from 20 to 380. And I'll just take out the 200 there in my code and put in a y instead of just the number directly. And then we should have a grid. Let's space this out a little bit. You can see this code is quite dense to read. So one thing that can be good is just to leave a little bit of space to make clear where the for loop starts, ends. I'm fiddling a bit now, but you get the point, I think. Minimize this so you can see it all. Yeah, so hopefully there it's clear to you that we've got one block of code, which is our, firstly, we've got a block of code that just draws our circle, and that's inside our for loop, our inner loop, and then that's inside our outer loop. And can you see how the indentation follows that structure? So we indent each time that we open a curly bracket. If you follow that rule, your code will will have this kind of structure that helps you read it. Right, that's creating a grid of squares, a grid of circles, a simple demonstration of the parts of a for loop. Hopefully, if you've had a bit of trouble getting the hang of a for loop, that might give you a start. And if you want to go further, look at some of the little activities in that third tutorial where it asks you to try and make them only on the left or only on the right or further spaced apart. That might help you get the hang of the initialization, condition, and update parts of the for loop. Right, in the next part, I'm going to make this grid reactive to the keyboard.